Okay, in this video we're going to look at trig graphs of the form y equals sin bx and y equals cos bx, and what effect the b has on the graph. Now we've already looked at when we have a sin x and a cos x. I made a 1 in this case, so it's not going to have any other effect on it, so it's 1 and 1, and it's only the b that we're going to be looking at. So here's the standard graph, sin equals bx, or sorry, sin equals bx, but in this case the b is 1, therefore we have the standard graph. And the things you should know about the sin x from the previous videos is it repeats itself every 360, maximum value is 1, minimum value is minus 1. And the maximum value occurs at 90 degrees, and the minimum value occurs at 270. So everything is going to be related to this standard graph for these other ones. So I've drawn this second graph, and you can see that we have 2 cycles in here within 360, so we've got double the amount of the standard graph, we've got 2 of them in there. And the equation for that one is y equals sin 2x. Seems quite logical. With 2 cycles, we have b equal to 2. The third graph here, I've got 1, 2, 3, I've got 4 cycles here. So based on what we've just done, so y is equal to sin 4x. So you can see the b value. The bigger the b value, the more cycles we have. So b is equal to the number of cycles within 360 degrees. Okay, so we have 4 cycles here, sin 4x. This one we will have 2 cycles, so b is 2, so sin 2x. And the standard one, only 1 cycle, so it's sin x. Now, another important thing about the trig graphs is the period. How long does it take to complete one complete wave? Well, in this case, the standard one, the period is 360. Remember, it's a circular function, so 360 degrees it takes to do one cycle. But this one here, we've got 2 cycles within 360. So the period of that wave, well, it repeats itself halfway, so it's 180. So we have 1 cycle within 180. So the period for this one is 180 degrees. And the bottom one there, we've got 4 cycles. So the first cycle is to here, and that'll be after 90 degrees. So the period of this wave is 90 degrees. Because it only takes 90 degrees for this one, because there's 4 of them within 360. So to work out the period of the wave for sine and cosine, it's 360 degrees divided by b. 360 divided by b, b is 4, is 90. That's how long it takes for one wave. And for this one, 360 divided by 2, 180. And for the standard one, 360 divided by 1, which is 360. So that's how we work out the period. Now that's things you have to know. Now these rules apply to the cos as well. Okay, so exactly the same for the cos. So let's look at a couple of cos ones. Let's look at this one. Well, this is the normal cos graph. It goes like that. And this would be 360 degrees. This would be 1 and minus 1. That's the minimum value. And the maximum value is 1. So, I'm going to draw an awkward looking one. If I only draw that, and if I say that's already 360 degrees, then the equation for that graph, well, it's a cos graph, so it's going to be y cos. I've only got half a wave in that, so it's going to be a half x. Okay, and remember that's 1 and minus 1. So only a half there. So the period for that wave would be, the period would be 360 divided by a half. Now dividing by half is the same as multiplying by 2. So if you work that out, it comes to 720. So it takes 720 degrees before this particular graph repeats itself. Let's look at another one. Let's do one cycle, then another half cycle. Okay, another half cycle. So that would be 360 degrees. So make that 1 and minus 1. So again, it's a cos graph. We've got 1.5 cycles. That's one cycle to here, and then we've got another half cycle. So that graph would be y equals cos, oh that's 1.5, so that's 3 over 2x. And the period of that wave, that's going to be a wee bit tricky, but the period for that is going to be 360 divided by 1.5, which is 3 over 2. Well, that gives you 720 over 3, and working that out, 3 into 7 goes twice, carry 1, 240 degrees. 240 degrees before it repeats. Okay, so that point there, as it a complete wave, would be 240 degrees. Right, let's try one last one. We'll do 1, 2, 3, just a little bit T in there. So we'll call that 360 degrees at this point here. Move that along a wee bit. 1 minus 1. Well, 1 cycle to here, 1 cycle to there, and then another cycle. Yeah, so 3 complete cycles. So this graph would be y equals cos 3x. And the period for this one is equal to 360 over 3, and that equals 120 degrees. So the period for that wave is 120 degrees. Now, the same rules apply for tan, but you've got to be careful with tan. I'll just put a wee note here. Well, tan, if you remember from the other videos, has a period of only 180 degrees. Okay, so tan's a period of 180 degrees. So, 180 degrees. So if we have tan 2x, then the period for that would be equal to 180 this time over 2, which would be 90 degrees. Okay, you've got to be careful of that, because the period for tan is only 180, not 360. That's the only difference between these things here. Okay, invariably in the National 5 exam, 99.9% of the time it's sine or cos that you get. You could get a tan, but very, very rare, and you'll have to remember the periods for the normal tan or the standard tan is 180. Okay, that's this video done. The next video is going to combine the A that we did in the last video with the B in this video to do a mixture. So we'll maybe try and do that in the next day or two. Okay, so that's us.